Alright, how's everybody doing out there today in Math Magic Land? This is Mr. Muscarella coming at you. And in this video, we're going to take a quick look at simplifying trig values using the half-angle formulas with special guest star, SOHCAHTOA. And if you don't remember what SOHCAHTOA is, we'll just go ahead and do that real quickly for you. So, remember back from your geometry days, you'd have a triangle, and it's got to be a right triangle. You'd have theta, so your angle is going to kind of depend, and that's going to determine where everything is. So based on where that angle is, this side over here, that's going to be OPP, or the opposite, and the one on this side is going to be ADJ, or adjacent, and then over here is going to be the hypotenuse. So the hypotenuse is usually just the H, and then the opposite is the O, and the adjacent is the A. So sine, the sine function is opposite over hypotenuse, so that's SO in SOHCAHTOA. And then the cosine is adjacent over hypotenuse, so that's the ratio of those two sides. And TOA is tangent, which of course is the opposite over the adjacent. All right, so just a little bit of review on that before we get into these. Now, the double angle formulas are quite a bit there, and so are the half-angled formulas. So go ahead and hit pause. Make sure you've got those formulas down in your notes, because you're definitely going to need them as we get ready to do those problems that we've got coming up for you here. Let's go ahead and hit pause, and then come on back once you have them all written down. Alright, so here we go with our very first example, and what you want to notice is kind of two things here. One, they give you this piece right here. They're like, okay, tangent is this ratio, so tangent is going to be some ratio right here. Now notice there's a negative sign right there, and I don't know yet if that goes with the top number or the bottom number, so stay tuned on that, stay tuned. And then the other piece of information they give us is like, all right, here, where theta, our angle, is between 90 and 180. So the very first thing you want to do after you notice those two things, of course, is you're going to want to draw where this triangle is, figure out what quadrant we're in. So we're going to take just kind of the coordinate grid, and we know this part, and we also know it's in quadrant 2. So our right triangle is going to be drawn just like this. Boom, boom, that's where the right angle goes. Theta is always going to go in the angle that's closest to the origin, the side of the triangle, the angle that is going to be closest to the origin. Sometimes it might be an X in there or a theta. Now, tangent, so now I have to remember SOHCAHTOA here. Tangent is going to be opposite over hypotenuse, so or opposite over adjacent. So I'm just going to put these two values in. 12 is opposite, 5 is negative. Now, I've got to analyze these two values and say, well, which one is going to get this negative sign? If you think about the XY coordinate plane, all right, your Y coordinate up in here, so if I just look at the Y coordinate, that value is always going to be positive. So if you think about XY, that's always going to be positive, which means this guy right here, the 5, that is going to be the one that gets the negative sign. So then we're going to go ahead and add that to the 5. So the 5 is the one that gets the negative 5. All right, so we've got our triangle drawn. That's the first thing. So step 1 is draw the triangle. Step 2 is we've got to find this missing side. So there's one other side that we do not have, and that's this guy right here. And I'm just going to call this R. I'm just going to call that R. We have to use Pythagorean theorem to figure out what that side is. So I'm going to tie this into the unit circle. I'm just going to kind of work this over here. So the x coordinate, x squared plus y squared, that's going to be R squared. Now we're going to use the Pythagorean theorem and figure out that missing side. So negative 5 goes in for the x, I square that, plus 12, and that quantity squared is going to give me whatever the radius squared is. Now 5 squared, of course, is 25, and negative 5 squared is 25, and 12 squared is 144. Ooh, I'm thinking ahead here. And that gives me R squared. Combining those, I get 169 for R squared. And then this is where you got to be careful. You do plus or minus the square root of both sides. So be really careful there. And that is going to be plus or minus the square root of 169 is going to give me R. And when I do that, I'll get 13 for R. Now, which value do I use? Do I use positive value or negative value for 13? Anybody know? Well, in this case, the radius, the hypotenuse, is always going to be positive. So I figure out that value, and the hypotenuse is always positive, so there we go. We've got that. So let me just kind of move this guy. I don't need you. So just this part right here. I'm going to move that, shrink that down a little bit. So that's how you find that one missing side. We use Pythagorean theorem. Now, it's just a matter, we've got all three sides of our right triangle. Now it's just a matter of plugging and chugging everything into our formula. So take your time. It's really super easy to mess that up. So we're going to go ahead and get after the sine of theta over 2 first. Now, here's something else I want you to pay attention to. Yeah, I think I might mention this now. All right, cool. This angle, the angle we started out with, is right here. We know that's in quadrant 2. But if I divide that by 2, then that's my theta over 2. And if I divide 90 by 2 and 180 by 2, that'll make that piece equivalent. So the angle that I'm trying to find, this theta over 2, 90 divided by 2, so I'm going to write this over here. 90 divided by 2 is 45, is less than theta over 2, is less than 180 divided by 2, that's 90. So the angle that I'm trying to find is over here between 45 and 90. So that's somewhere in this quadrant right here. So somewhere in there would be the angle. And of course, we know that that's going to be quadrant 1. And everything in quadrant 1 is positive. So whether I'm finding sine, cosine, or tangent in quadrant number 1, we know that that's going to be positive. Because of course, we remember this little thing where it's like everything's positive there. All sine is positive in quadrant 2. Cosine, or not cosine, I'm getting ahead there. Cosine is positive in quadrant number 4, but tangent is positive in quadrant 3, and cosine is positive in quadrant 4. So anyway, I digress. Let's go ahead and get after sine of theta over 2. Now the formula, so plus or minus the square root, then I have 1 minus cosine of theta all over 2. Now one thing I'm going to do is I'm going to offer you a little bit different way to write this. So maybe pull the 1/2 out in front. And then you're just going to have the numerator 1 minus cosine of theta. Sometimes that'll make things a little bit easier for you with some arithmetic we've got going on. But in a lot of textbooks, they just show it as 1 minus cos theta over 2 with the square root and all that. So we're going to go ahead and then just plug in. So we have the 1/2, that stays put. And then cosine, I have to look here at my units, or not the unit circle, but this nice little drawing we've got of our triangle. Now cosine is going to be the adjacent side over the hypotenuse. So adjacent over hypotenuse, that's going to give me that ratio of -5 over 13. So then I'm going to have minus and then -5 over 13. So that's what goes in for cosine of theta. Don't forget, wrap your square root on all that. Be nice, neat, and organized, of course. And then we do plus or minus, and we have 1/2 minus -5 over 13. That's going to go to plus 5 over 13. And since I've got 13 in my denominator, 1, so this 1 right here, this guy, that's going to change into, I want to have the same denominator as the other part of my fraction, so that's going to be 13 over 13. And I'm doing that because it'll help me combine those two terms when I add them. Now 13 over 13 plus 5 over 13, that's going to give us 18 over 13. So I've got that part, so my 1/2 out in front, and there's a big old square root around the whole thing, or plus or minus out in front. You can notice right here, so this 2 goes into 2 once, and 2 goes into 18 9 times. So that's going to help us a little bit as we clean some things up here, because this is just really tedious and time-consuming algebra, but now I'm going to have, the 2 is going to be gone, so I'm going to have 9 over 13, and then my square root around that. So where do we go from here? Now there's a couple options. Square root of 9, that's pretty cool. I know that that is just 3. In the denominator, I'm going to have still my square root of 13. And you can't have a square root on the bottom because math people, we all yell about that kind of stuff. So you can rationalize that. So you have to multiply top and the bottom by 13. And then, wait for it, this is the grand finale here, you're going to have 3 square roots of 13 all over 13. And again, because I'm in quadrant 1, I can ditch the plus or minus there because I'm going to be dealing with the positive version of that value. So the sine of theta over 2 is just 3 square root of 13 over 13. Man, that's a lot of work. Now what I want you to do is go ahead and do the same thing for cosine. Go ahead and try that one, and then we'll go ahead and take a look and see how you did. So hit pause, try and find cosine of theta over 2, and come back and check it out when you're done. All right, so how did you do with this one? Hopefully you did okay. And again, you have that option of pulling that 1/2 out in front. It just makes it a little bit nicer and cleaner. But I wanted you to pay attention to is this little highlighted part right here. So I know I've got 1, and then when I plug in the ratio for cosine, -5 over 13, I want to change that 1 to have the same denominator. So that's going to end up being 13 over 13. That's just a clever form of 1. So that way that allows me to go ahead and add 13 plus -5 a little bit easier. That, of course, gives me 8. So I'm going to have 1/2 times 8 over 13. 1/2 times 8 over 13. I cancel and I simplify on the inside underneath the radical first. And then I'm going to go ahead and have that piece right there where it's just square root of 4 over 13. I'm going to do all my simplifying all the way down. I'm just going to get to this grand old nice little thing right here where I have plus or minus 2 over 13. And again, at the end, I know cosine, all right, because when I look at theta right here being in quadrant 2, everything is positive right there. So it doesn't matter whether I'm dealing with sine of theta over 2, cosine of theta over 2, or tangent of theta over 2. My final answer is always going to be positive. All right, so that's for cosine of theta over 2. Now go ahead and, if you got that one, you're good with it. Hit pause and then try to do tangent of theta over 2. When you're ready, hit pause again and coming back to see how you did. All right, so how'd you do with this one? Tangent of theta over 2, man, that is a lot of work. Now, again, one of the things I want you to kind of pay attention to a little bit right here, like I know these ones right here, because I've got 13 in my denominator there and there, I know each one of those are going to change to 13 over 13. So I'm just going to do that right at the beginning, kind of save myself a little bit of time here. And then on this next step right here, so this is what's kind of cool when you do the arithmetic there. So 18 over 13, this 13 and this 13 right there, since they're both on the bottoms, they're going to go ahead and cancel out. So if you recognize that, that's pretty cool. I mean, you could always do keep, change, flip, where you'd have 18 over 13, instead of divided by 8 over 13, you do times, then flip it. So 13 over 8, and of course you can see where they both cancel out. So either case, that gives you this line right here, that square root of 18 over 8. And notice through all this, since I knew tangent of theta over 2 is going to be in quadrant 1, I didn't bother with the plus or minus because I knew the whole answer was going to be positive. All in all, we end up with 3 over 2 when we're done doing all that arithmetic. And that's a lot of crazy stuff. But how do I even know if I got that right? So what I want you to remember is this little relationship here between sine and cosine and tangent. Because tangent, remember tangent, so let me see, where do we have some space? Yeah, we're going to write this right here. So tangent, remember, that's the same thing as sine over cosine. So one of the really cool things, I'm going to look at this version of it right here and this version right here for my sine of theta over 2 and cosine of theta over 2. And I want you to play along and see kind of what happens here. So if I take sine and divide it by cosine, so sine is going to be that 3 over square root of 13. And then my cosine part is, that's the other piece over here. Cosine of theta over 2 was 2 over square root of 13. Now I'm going to run into that same thing that I did before where it's like, oh, both of these guys right here in the denominator, they're both the same. That's gone, and what am I left with? Holy cow, it's almost a little miracle on ice kind of thing. 3 over 2. And notice that's the same thing I got over here. So that is one of the ways that you can check yourself before you make sure you got everything. So that and that jive, which means all of this, I did that correctly. Man, you got to pat yourself on the back after that, junks, because that's just crazy a lot. But remember, the key thing you've got to do, so first thing was set up the triangle and draw that. The second thing was find the missing side using Pythagorean theorem. And then the third thing is just take your time and plug and chug in each one of those formulas. All right, you got this. All right, thanks for watching this video. I got one other example for you if you want another one. And you can watch that one separately on your own. But that's it for this one. You guys have a great day, good evening, and good night. Peace out.